As we pursue electrical generation from wind and solar, we should consider other factors as well. Because both are highly variable generating sources over time, the need to store electricity when it is generated for use later when it is actually needed remains an ongoing significant challenge. Many battery designs and other schemes to address this problem are being pursued, but solid breakthroughs so far are proving elusive. New battery designs often are based on the use of expensive new materials with limited availability. Accordingly, progress will likely be slow for some time. For example, the issue of achieving adequate scale in addressing the storage of renewable energy has led the Brookings Institution and other macro policy think tanks to contemplate the merits of a new smart electrical grid capable of delivering green-generated electricity to individual households where it can be selectively stored and, if needed elsewhere, periodically retrieved from the battery packs of hybrid electric or all-electric vehicles. A prototype of this ingenious idea for a storage system has been tested and, in effect, lab bench validated. However, to expand it to the scale required for the vast U.S. economy of more than 300 million people involves a whole series of chicken versus egg obstacles. In other words, the degree of market acceptance required to achieve a critical mass of actually installed vehicle battery packs is a formidable task in itself. Beyond that, there is the required widespread installation of a brand new green grid for the necessary connectivity of this diversified storage system. Can the key capital-intensive components of such a complex be developed simultaneously to create this admittedly elegant vision of the future? A recent New York Times article detailing the travails of Fisker Automotive's efforts to build a competitive electric vehicle is instructive as well as sobering. The problem is further compounded when one contemplates the possible, and even likely, open market challenges to electric and hybrid vehicles posed by natural gas as well as much more efficient traditional gasoline engine vehicles. An additional, somewhat related problem involves the need for standby generation that can be brought online quickly to replace wind turbines when the wind dies down and, equally important, can be readily shut down when the wind picks up. In today's world, natural gas is the main option for achieving this. As a rule of thumb, for every unit of wind-generated electricity, about 1/2 a unit of standby, that is, fully developed but usually non-producing, natural gas generating capacity is estimated to be needed. In the current environment of modest economic growth and given the current level of excess natural gas production capacity, the ability to address this need for backup generating capacity is fairly easy to achieve. In future periods, with the prospect of higher calls on the developed natural gas production base, however, the same may not be true.